Welcome to This Explainer. I am absolutely thrilled you're here today because we are going to uncover the hidden mathematics of our global energy infrastructure. We live in a world entirely built on a very specific type of energy paradigm, but the numbers we see every single day, they're hiding a massive systemic inefficiency. Today, we're going to break down the heavy, physical reality of commodity energy, specifically oil, and contrast it with a completely different kind of infrastructure, a total paradigm shift. We're looking at the true cost of energy. Oil versus Oikonomia. Okay, let's dive into this. When you pull up to the pump, or maybe you see a massive diesel tanker roaring down the highway, you see a price on a sign. Maybe it's $3.50, maybe it's $4. And we are completely conditioned to look at that number and think, all right, that's what energy costs. But that gallon metric, it's honestly an illusion. It is a completely deceptive way to measure the actual work that energy does for our civilization. To really understand the cost of our infrastructure, we have to strip away the gallons and the barrels and look at the fundamental unit of usable energy, which is the kilowatt hour.
So let's actually crunch the math here for a second. 1 gallon of gasoline contains about 33.7 kilowatt hours of raw chemical energy. If gasoline is priced at $3.50 a gallon and we divide that by its 33.7 kilowatt hours, we get a baseline of about 10.3 cents per kilowatt hour. For diesel, it's a very similar story, right around 10.4 cents. Now, on the surface, that looks pretty reasonable, right? 10 to 12 cents per kilowatt hour under normal conditions. But this is exactly where the grand illusion of commodity energy begins. Because that 10.3 cents, that only pays for the raw, unburned chemical potential trapped in the liquid.
Section 1. The hidden reality of oil, thermodynamic and geopolitical penalties.
To understand why that 10-cent baseline is totally misleading, you have to picture the documentary-grade reality of this system. We're talking massive offshore rigs, rust, heavy machinery, flare stacks burning off gas, thousands of miles of pipelines. This is a heavy, physical, dirty commodity that has to be relentlessly forced through the physical world. And as soon as you try to turn that liquid into actual motion, you are hit with a massive, relentless thermodynamic penalty. Let's just trace where your energy actually goes. First, engine inefficiency immediately strips away a huge percentage of it. Then, you have massive heat loss, literally just radiating out into the atmosphere. Then you're battling mechanical friction. You have idle cycles where fuel burns while the machine does absolutely zero useful work. And finally, transmission losses. The raw chemical energy is physically drained and exhausted before it ever turns the wheels of a truck or powers a generator.
So, the crucial point is, the actual usable energy cost of oil is massively inflated once it goes through this physical gauntlet. When you account for all of those thermodynamic losses we just talked about, that 10.3 cents we calculated earlier completely vanishes. The true cost of the usable energy that actually powers our world is closer to 25 to 35 cents per kilowatt hour. You are paying a massive premium just to overcome the physical friction of combustion.
And thermodynamics? Well, that's honestly only half the problem. Oil is inherently chaotic. Because it's a physical commodity extracted from very specific locations on Earth, it's tied to a highly fragile supply chain, fraught with global bottlenecks. The price of this energy is entirely at the mercy of wars and geopolitics. A supply shock on the other side of the planet, a single refinery outage, a shipping tanker getting stuck in a canal, or a closed-door OPEC decision can radically alter what you pay. It is fundamentally volatile.
And when that volatility actually strikes, it threatens the entire system. Just look at this scenario. If oil spikes to $150 or $200 a barrel, which, by the way, we have seen happen multiple times in recent decades, gasoline jumps to $6 to $8 a gallon. That pushes your base energy cost up to 24 cents per kilowatt hour, and that is before the thermodynamic losses we just walked through. This creates a catastrophic civilization-level cascade. Diesel supply chains break, food prices spike, logistics costs completely explode, and inflation accelerates wildly.
All right, Section 2, the paradigm shift. Enter Oikonomia.
We are pivoting sharply now. We are leaving behind the dirty, chaotic, extractive reality of oil rigs and price shocks, and we're stepping into the clean, geometry-heavy precision of modern compute infrastructure. We're talking about replacing a volatile commodity with a completely stable foundation. So what exactly is Oikonomia? It's a computational substrate that produces stable, predictable, near-zero marginal cost energy for systems. And this brilliantly illustrates that Oikonomia is not a fuel at all. It is pure compute. Imagine rows of immaculate server racks, deterministic timing diagrams, city-scale orchestration. It's a foundation built on data and processing, not on extracting ancient liquids from the ground.
Because it's pure compute, look at what is entirely eliminated from the equation. There is no extraction or refining, no shipping or depletion, zero geopolitical risk, no combustion losses, and absolutely no thermodynamic penalty. Oikonomia operates with zero drift performance. It completely bypasses the physical and geopolitical friction that totally plagues commodity energy.
And because it bypasses all of that friction, Oikonomia achieves a flat deterministic cost of just 1 to 3 cents per kilowatt hour. Think about that. This isn't a price that fluctuates based on overseas conflicts or refinery fires. It is a highly predictable structural cost. It's basically a fundamental resetting of what it actually costs to power complex systems.
Let's move to Section 3 and see how this builds. Volatility versus stability, a system comparison. Let's look at a really stark contrast between these two regimes. We have the chaotic legacy system we've inherited and the deterministic substrate that we're shifting toward. When you look at them side by side, the difference is absolutely staggering. On the one hand, oil's true usable cost pushes up to 35 cents per kilowatt hour. On the other, Oikonomia sits calmly right at 3 cents. We are looking at a 3 to 10 times cost difference. And because oil relies on depleting resources and aging infrastructure, while compute scales infinitely with better technology, this massive gap inherently widens every single year.
It's really a tale of two entirely different physical realities. Oil is volatile, extractive, depleting, and constantly subject to price shocks. It requires incredibly heavy, polluting infrastructure. Oikonomia, on the flip side, is stable, predictable, infinitely scaling, and deterministic. It's infrastructure light and fundamentally clean. Let's break this down systematically, because this shows why Oikonomia isn't just a cheaper option, it is structurally superior. The nature of oil is a commodity. Oikonomia is a substrate. Oil has a high marginal cost, meaning every extra gallon costs real money and effort to dig up. Oikonomia's marginal cost practically approaches zero. Oil is entirely exposed to geopolitics. Oikonomia is completely immune. And ultimately, oil's behavior in the market is incredibly volatile, while Oikonomia is perfectly deterministic. You know exactly what it's going to do and exactly what it's going to cost.
Section 4. Civilization scale impact, beyond cheaper energy. Let's zoom out to the macro level for a second. If we are moving from a system of 35-cent volatile energy to 3-cent stable compute, we aren't just talking about saving a few bucks, we're talking about the global implications of replacing commodity energy with completely drift-free infrastructure. Think about what happens when you lock in energy at a stable 1 to 3 cents per kilowatt hour. It revolutionizes literally everything. Global logistics can operate with perfect predictability without fuel surcharges destroying margins. Emergency response networks never fail due to grid spikes. We can run massive city-scale system simulations. It transforms city infrastructure and ultimately guarantees national resilience. Oikonomia basically acts as the ultimate civilization insurance against global chaos.
Now, what's really interesting about this slide is the profound gravity of this statement. Oil is a resource. Oikonomia is a regime. A resource is something you dig up, you burn, and you deplete. You fight over it. But a regime? A regime is a set of rules, an underlying architecture, a foundation that dictates how everything built on top of it behaves. By moving to Oikonomia, we are fundamentally upgrading the operating system of human civilization, from chaos to order.
Which brings us to our final thought. We spent over a century optimizing a fuel that loses most of its power to heat and friction, and holds our global economy completely hostage to volatility. But right now, we have a pure computational foundation that is immune to geopolitics, completely ignores thermodynamic penalties, and scales infinitely at near zero marginal cost. Oil is a fuel. Oikonomia is a foundation. So the only question left is, what will you build on it? Thanks so much for joining me on this explainer, and keep exploring.